Points underlie everything in computational design. Of course, they underlie a lot more than just that. They're fundamental in the way that we talk about space, in the way that we think about space, well beyond computational design. But they're so simple and so fundamental to us here. They are simple, but they're not boring. The concept of point is a very powerful one. Points are quite powerful, especially in their relationships with each other. Points are vectors when we cast them in relation to an origin. Their pushes and pulls and pressures and velocities changes. Points allude to attributes, or they describe attributes, fuzzy or crisp. They're nodes in a network. They're essential tools in mapping complex relationships. They collect or disperse, congregate or repel. They communicate. They define space and reveal patterns. They prompt understandings or invite second guesses. They tease something almost recognizable. They reorient us. They're central, global, universal, usually hidden, an essential construct. So let's construct some constructs. Here we're going to work with the construct point component. We'll make a point, then lots of points. Then we'll let these points define some surfaces. So let's open up Grasshopper. And let's double click on the perspective tab and zoom way in here. We're just going to type construct point. And you can see a point appeared right at the origin. The easiest way to use this is to just plug in x, y, and z coordinates. So if I type -10, or let's just go to -1. 0.000 is less than 0 is less than 1. Then I'll get a slider between -1 and 1 with 3 decimals. And if I click Alt as I drag this, then they multiply. They duplicate each time I press Alt. And then we can plug these in, x, y, and z, and we have a point there that we can move around. So that's the most straightforward way to use this. Another way is, let's get another construct point component. And let's get a range component and a slider between 10 and 100. So I'll just type in 10 is less than 100. So what this is going to do is give me a range of numbers between 0 and 1. So right now there are 11 different numbers going from 0 to 1. But as I increase this, then we have more divisions. So now there are 29 because we have 0 and 1. There's always one more than this little number input indicates. So we can do a lot of different things with this range component and the construct point. First we can move it. If I type move on the canvas, then now I have a move component. And I'll type x to get a unit x. And I'll plug this in there. So what this is giving me is 29 different vectors, or 28 actually, because the first one is a 0 vector. And so if I plug my point in there, then I've just moved that point 28 times, including the 0 vector, so I have 29 different points between 0 and 1. If I increase that number, then I get more points between 0 and 1. I can also graft this, and if I duplicate this component, and I type y, and then I click right here on unit y, I put that in, the same output that's coming from this range component, into the y, and I put that in here. You can see now we have points going from 0 to 1 in the y direction. I won't go too deeply into what grafting means, but basically that means that every point in this list that's coming out of here, all of these green ones, is if I plug it into here, every point is going to be moved in the y direction. So it's going to treat each point as if it's a separate list, and it's going to make a new list out of all of those points. So that's an easy way to start making some geometry just from the construct point component. We can also do something very similar to this just by putting numbers into the inputs for x, y, and z, lists of numbers into all three of these. So let's get another construct point. And I'm going to hide all of this for now. Now we just have our one point at the origin. Let's use this range component again. I'll just pull it over here. And let's get a cross reference. So what this is going to do is this, for every list going into here, it's going to match it up with a list going in here. So right now I have 28 values going into A and 28 values going into B, and coming out of A is 784 values. So let's do some math quickly. 28 times 28 is 784. So all this is doing is matching up list A with list B. So if the first item in list A is 0, and the first item in list B is 0, then coming out of here is going to be 0, 0, and then it's going to be 0, 1, and then 0, 2, and then 0, 3 if we were going up by increments of 1, but we're not. We're going up by decimal points. But anyway, all we need to do now that we have these two very long lists is plug those values into x and y, and we have basically the same thing that we had up here. Actually, we have the exact same thing, except the data is organized a little differently. Another thing we can do is vary the z values based on the x and y coordinates for each of these points. So to do that, I'm going to get a remap numbers component and a construct domain component. And let's use sine, the trigonometric function sine. So pi is also helpful when we're working with sine and cosine. So I'm going to get a pi component, and then I'm going to type 1.000 is less than 8. And so what this pi component does is it takes whatever the input is into this in input, and it multiplies it by pi. So coming out of y right now is just pi, because we have 1 times pi. And what this construct domain component is doing, this default input is 0, this one's pi, this is making a domain between 0 and pi, which is what we need for our remap numbers component. We want our domain to go from 0 to pi. Right now, this domain coming out of here is from 0 to 1. We have numbers going from 0 to 1. And that's the default for our start domain, our source domain, going from 0 to 1. So these numbers are already going from 0 to 1, but we want to change them from 0 to 1 to 0 to pi. So this is just going to scale all these values accordingly. So I just clicked Alt to get another component. So now we have numbers that were going from 0 to 1, now they're going from 0 to pi. Now let's get a sine component. So all of these numbers, we're just putting into the function sine, and then whatever comes out, this is like y equals sine x. X goes in here, we take the sine, and then that's the output is y. Let's add these together. And let's multiply the output. I'm going to go from 0.000 to 0.25. This is just to scale the output a little bit. Sine function puts out values between -1 and +1. And if we will go to +1 and -1, these z values are going to be very high, so I'm just going to make them a little bit smaller by multiplying them by a number that's smaller than 1. So then we can just plug these into our z's, and now we have points that vary a little bit according to their xy coordinates. And we can change this a little bit and get some different geometries. I'm going to type grid, then H, enter, O, enter, and that will get rid of the grid in Rhino. So this is a very simple equation and a pretty simple almost surface here that we have of the points. Of course, if you have more complicated equations like these, and we have a construct point, let's hide this, then you can get much more complicated geometries. You don't need to have these complicated equations to create a geometry as complicated as in Rhino, but you can do it just with the construct point component. These equations come from the pasta mesh tutorial. If you're interested in seeing more on this, just follow the link to that tutorial. Or if you'd like to explore something more advanced than that, follow the link to the marching cubes tutorial. After we make a lookup table in that one, we use the construct point component to get us started in the actual algorithm and to visualize the space we'll be modeling. It's not at all uncommon to start with points. Actually, it's very common. They are quite literally fundamental. But these are just a couple quick examples I can throw out where this particular component, the construct point component, plays a central role in at least one major part of it. Anyway, please subscribe if you think you'll be watching more of these tutorials. There are many more to come. And thanks so much for watching. See you on the next one.